Okay, so when we talk about matrix, a matrix, and I said this on another slide, but I'm going to go ahead and say this in case I use the word interchangeably. Matrices is plural, and you're going to see these on the next page. You're going to see 2 matrices. Okay, so this is your basic order, A, B, C, D. So like your matrix either goes like this, or it goes AD, or it goes CB, and it can also go CBD. That's basically your orders. Okay, so just look at where they're positioned. A and B, same line. C and D, same line. Get that straight, because most of your matrices in math are going to be done with numbers. Okay, so when you get ready to do a matrix, and this is called a 2 by 2 multiplied by a 2 by 2. Now some people say, isn't that a 2 by 4? It's not a 2 by 4 unless you go like this. A, B, C, D, and you almost can't, it should really be C, D. I'm sorry, what was I thinking? E, F, G, H. So this is really a 4 by 2. 4 here in this row, and 4 here in this row. And so that is called really a 4 row. It's a 4-4. Well, it's a 4-2. It's two rows. It's 4 elements and 2 rows. Okay? It's 2 rows, 4 elements, and so there. So you'd have to have 4 in 1 row. But back to this. This is your basic structure is just one of these. Okay? So when we get ready to go on to the next slide, this A is going to be replaced by a number like 3. B is going to be replaced by a number. Right now, these are just number placements. Okay, this is a 7. And I'm just going to do a number out of 2 so that you can see what happens. And A, B, C, D is used as alphabet to let you know the order, not as numbers. So that like if you had an equation that said A 2 plus 5, this is in brackets, so this would be 7 times this, which would be 21. Okay? And remember, brackets mean that you're multiplying. So A's location is 3. So that would be 21. Okay, so all you're doing is looking at where locations are. All right, so then you go on to the next slide. So we're going to talk about matrices and determinants as they go in a line. Now, if you ever think about what a matrix is, there is a movie called The Matrix with Keanu Reeves and Lawrence Fishburne. But these brackets means that it's what? It's contained. And your matrix is contained for a reason, because it wants you to do something. Now, here's what's going on when you have these brackets back together like this. This is a multiplication and an addition matrix. And you have to take care of what's contained first. And here's what makes matrices, by the way, the English in me comes out, not the British English, but the standard American English. When you do matrix, you pluralize it and it becomes matrices. Okay, so that's singular matrix and that's plural. But anyway, so this multiplication and addition. Let me tell you how you could make this multiplication and subtraction. One of these would be negative. And that's all you have to do. But along the way, here's what makes matrices like this. And by the way, this is called a 2 by 2 matrix. Why? There's 1, 2, and then there's 2, 2 columns. So it's a 2 by 2 matrix. And it's multiplied by another 2 by 2 matrix. 1, 2 rows, 1 row, 1 row equals 2 rows and 2 columns. One column here. Oops, there I go. Sorry, guys. I mean to do it straight. So you have one column here and one column here. And so that is a 2 column. Okay, now, knowing this, we're going to multiply and add. So what are we going to do? We're going to take this element by all of this. This element has to go by this. And then guess what has to happen? This element has to go by this, and this element has to go by this column. So this number in this row has to go by this. All of them have to go. But here's the tricky part. This looks like a mess. Here's what you have to remember. When you get ready to go, you go 2 times 5. So you go over, you take this column, and you go 2 times 5. Then you do this because you're contained in a matrix, and you go 4 times 7. Hardest part when I first started learning this, I wanted to go 2 by 5 and 4 by 5, but you cannot. It's 2 by 5, 4 by 7. So if you can process left, down, and then, left, over, however you have to process. If you go left and over, and then left and down, left and over or left and down, however you can do it. But this element takes care of this, this element takes care of this. Okay, now you're going to do the same thing for these elements. So it's like you're containing things in a cell. And a lot of this is how your DNA gets processed. Okay, you're containing things in cells, and they can't come out of this matrix container, that's the brackets, until they do things. So now you do the same thing, 2 times 6 and 4 times 8. And then you have this. Now, why am I putting an addition sign here? Because in order for us to get what the answer to this matrix is, we have to add it. And you put this addition sign because you have no other choice. You don't know what else to do. So this was 5 times 5 and 6 times 7. And then let's do this, 5 times 6. See how it's going over here and going, hey, I'm going to go get you. And then, hey, 6, I'm going to go get you. Kind of like when your DNA is getting ready to process. It goes A, T, C, G, and, doing different things before they start doing the splicing. And you guys learn this when you're doing your meiosis 1, 2. So that's what's going on. All right. So now, guess what we're doing? Remember I said we had to add? 2 times 5 is 10. See how this is 10? 4 times 7 is 28. And there's 28. Now, we don't just start adding all of this. You take things by column, just like your DNA does. 5 times 5 is 25. 6 times 7 is 42. 2 times 6 is 12. 4 times 8 is 32. 5 times 6 is 30. And 6 times 8 is 48. You're not done. Don't just start doing things. Please don't rush ahead and think about what you're doing so you get them across. So now you add these across, and this is 38. This across is 67. 12 and 32 is 44. It's here. 30 and 48 is 78. And now, here's the answer to your matrix. All of that work to get this little answer, but guess what? It's happening. It is happening. And there you go. So this is the formula for a reversal. Okay, 1, because anything that goes underneath the line here, or underneath the denominator, it becomes negative. And that's why this -1 is up here. So this is your reversal, D, negative B, negative C, negative A. So what happens is this A comes down. And do you see it goes over here? The D goes up here. And the B becomes negative. You just have to accept this. This makes no sense, but you have to accept it. And the C is over here. So what's happening is, remember in the other reversals, AD, BC, you went like crisscross, like you were folding your elbows. Well, this is what happens here. A and D minus B and C. But your minuses show up here and show up here. So you put the D here and the A here. So you just kind of like keeping them on the same diagonal. But like if you were playing a chess game and D were here, you just turn around and you go, oh, I'm just going to reverse these. And put the D here and the A here. And then this was B, C. So I'm going to keep this negative. Then I'm going to make this negative. And then I don't have to move anything. That's what you're doing. This is one of the hardest things to remember. So if you don't remember it, that's okay. That's what's going on here. And then these brackets just mean there's a matrix. I just want to show you what to do. I'm going to take them off because I think they add to the confusion of you memorizing it. But that's really what all a reversal is. So if you can get this, you can get the other part of matrix. So this was one of the matrices from the original matrix 2 by 2. So 2 and 4, 5 and 6. So this is A. Right? This is a position where A would be. This is B. This is C. This is D. So when you reverse, you go D and A, swap places. Okay, so this 2 would come down here, and this 6 would go up here. And then you just put negative signs on B and C. So did we do that right? Did we put a 2 here, a 6 here, and a -4 and a -5? It's your basic reversal. Basic reversal. There are other types of reversals. This is basic. Okay, just to show you what you can do when you do matrices, you're encoding, and this is taken out from one of the textbooks used in 10th grade Algebra 2. This is just to show you how it's used like in computer science and in things. This matrix was encoded using matrix A equals, now here, before you do this, don't pay attention to this. This is how they code the alphabet because it's part of the question. Okay, A equals the first letter of your alphabet, B equals the second letter of your alphabet, but don't pay attention to this right now. Look at what matrix A is. Matrix A is when X is equal to 2, 1, -2, 5, 3, 0, 4, 3, 8. Then when it was encoded, you got alphabet. So now you're going to encode, this is 3 times 2, which is -6. This is -3 times 1 is -3. -3 times -2 is +6. So you've got to look at what's going on and how it uses the alphabet. So we're going to try to do this on the next slide. Just look at the alphabet. You know, Z is a 26 letter, J is a 10. Try to think of this, and I'll have this in the corner.